pleasure to be invited to present my research work on the paleoclimate reconstructions from Northwest India in the context of Indus cultural transformation today. Most of this work was done as a part of my PhD research at the University of Cambridge, and I continue to work in this field with my team now at IIT Delhi. My talk today will focus on what the lakes in Northwest India tell us about the climate changes during the last 10,000 years, with a particular focus on the Bronze Age period. So the map here shows location of paleo lake records in black triangles. There are also orange circles which denote the Indus settlements in Northwest India. These were taken from Professor Cameron Petrie et al. From Cambridge, and the red dots here are the urban Indus centers that you see. So white lines are of particular interest because these are the isoheights, that is line joining equal precipitation, and the inset is basically the map of the Indian subcontinent. Now, Indus civilization spanned a range of environmental zones, as can be seen on the map. So they were lying in the subhumid region, receiving rainfalls from 600 to 750 millimeters. Semi-arid region also, Rakhigarhi, for instance, was one of the urban centers there, receiving 500 to 600 millimeters of rainfall, and arid region receiving less than 400 millimeters of rainfall. Now, Indus societal changes over the last couple of decades has been linked with climatic changes that were reconstructed from various archives. The map here is a physiographic map of the Indian subcontinent, and which shows also the adjacent ocean regions with a schematic of surface wind patterns. So the blue arrows that you see indicate the general directions of the Arabian Sea and the Bay of Bengal branches of the Indian summer monsoon. The yellow dashed line denotes the position of the intertropical convergence zone during the northern hemisphere summertime, with lower atmospheric pressure on land denoted by L and high pressure over the ocean denoted by H in the map. The annual reversal of the surface winds caused by the north-south migration of this yellow dotted line, the ITCZ, is thought to create a global summer monsoon across the Indian nation and tropical African and also Australian landmass. Now the map also locates the prominent marine speleothem and lake proxy records, which will be discussed in this talk, and these are the records which are often linked with the cultural transformation of the Indus civilization. My main focus would be on the records that are there in the blue square in Northwest India, particularly the northwestern Indian lake. Now, one thing before I start is that these prominent climate records show a very different and divergent history of summer monsoon rainfall, and therefore there are some important questions that arise, which is that can Indus cultural transformation be faithfully linked with the climate reconstructions from far afield regions, and if not, whether the local or the lacustrine sequence from the regional lakes, do they tell the local climate history or the global climate reconstruction or climate history? Now, over the past couple of decades, the role of climate in the Indus cultural transformation, in particular the so-called collapse of the urban centers, has been debated. And this leads again to an important question as to which record is the most appropriate to test the climate culture theory in the case of Indus civilization. Going back to the previous slide, is it the local records or the regional records, terrestrial records, or the far field marine and speleothem records? So I'll be mostly talking about the local, the regional records in Northwest India. So Holocene climate reconstructions from several lakes in Northwest India will be presented. So the table here shows the lakes that I'll be talking about. So the lakes are kind of arranged from east to west direction. Lakes with reasonably robust chronology, that is, each major lithological and sedimentological and geochemical transition, if it is age constraint, they were used to infer regional climate history. The lake and proxies used from east to west, that is right to left, are subhumid region is Kotla Dahar with del 18O of gastropod shells, reflecting the regional evaporation by precipitation changes. In the semi-arid region, there's Rivasa with again del 18O gastropod reflecting the regional EYP changes. Arid region and the Thar Desert region has Paleo Lake Karsandi with del 18O of gypsum hydration water reflecting lake water isotopes, and again regional hydrological changes. Now lake levels are also shown from Prasad and Enzil 2006 paper, and then Didwana and Lumkransar records would also be taken into consideration. Now it can be noted that the age definition is quite poor in the case of Sambar Lake, with only 5 dates for the last 22,000 years history, and also for the Bab Malar and Kanot Playa in the westernmost site, which has only 6 dates for the 15 kiloyear history. So they will of course be taken with a pinch of salt. Now, before delving into the detailed climate reconstructions from Northwest Indian lakes, it is important to understand the role of insulation in driving monsoon changes, and in turn the appearance and evolution of lakes over the last 10,000 years, or the Holocene. Here is the Northern Hemisphere summer insolation record across the last 20,000 years. Note that the age is on the x-axis. It can be seen that the orange shaded region denoting the Holocene has the highest insolation at around 10 kiloyear BP, which led to intensified summer monsoon in the region, and which in turn filled up a lot of lake basins, and thus most of the lakes in northwest India actually appeared around 10 kiloyears. Now these are the climate records tagged on the right. They show from east to west the precipitation gradient. So vertical gray bars are also there, and these are the lakes which don't have very well defined ages. Green shaded bars denote the wettest period during the Holocene, inferred from geochemical proxies, although these wet periods were interrupted by intervals of aridity. From the figure, it is clear that there are considerable inconsistencies in the timing of high lake levels and drying. What is important to see is that the red dashed lines marked on top of each of the record is basically the disappearance of permanent lakes, such that the sequence of drying follows the modern day east to west path of Bay of Bengal branch of monsoon. The lakes that lie farthest in the west dried first. In this case, you can see that the Bap Malar and Kanod, and also lake levels in Lumkransar kind of went down or lowered first, and the easternmost Kotla Dahar became ephemeral the last. So, however, to understand the fidelity of these reconstructions in recording summer monsoon history, I'll discuss the Holocene period in 3 parts. So early Holocene would be from about 11 kiloyears to 7 kiloyears BP. There's also in gray I have ages in BC for the archaeologists' friends. This period was marked by intense monsoon rainfall, and maximum lake levels occurred in the eastern lakes in semi-arid and subhumid regions. However, low lake levels were recorded in the Thar Desert lakes. So the most plausible explanation for low lake levels during this intense monsoon period, and as we have discussed, intense insolation, is that this was a period of really high evaporation rates because of intense insolation, and also Thar Desert lakes lacked the large lake basin required to maintain high lake levels during this period. So in the mid-Holocene, however, between 7 to 5 kiloyear BP, this was characterized by relatively lower lake levels in the eastern lakes, that is lake in Rivasa and Kotla Dahar, but high lake levels in the arid Thar Desert region. The low lake levels in the eastern lakes now can be explained by the fact that the monsoon strength declined in response to the decreasing insolation, as can be seen in this figure on the top insolation figure. However, Thar desert lakes now record high lake levels because of relatively lower evaporation during this declining insolation. And an additional source of moisture is also proposed to be kind of coming in until the middle of the Thar Desert region during winter time by Enzel et al. And more recently by Elena Geshe et al., which kind of maintained this high lake level during the mid-Holocene. Now, late Holocene period is a period of interest, as this is a time when Thar Desert margin saw considerable changes in terms of Indus settlements. Lakes in the Thar Desert at this point reached the present-day ephemeral phase. So after 5 kiloyear, these lakes kind of were not permanent and they dried up and became ephemeral. So before the Indus population inhabited the region, Thar Desert lakes were already in the ephemeral modern day stage. However, Kotla Dahar Lake record in the east shows that the lake reached its present day ephemeral stage after an abrupt drying of about at around 4.1 plus minus 0.1 kiloyear BP. Now this abrupt drying is not apparent in any of the Thar Desert records because they were already in the present day ephemeral form. This 4.2 abrupt monsoon weakening event recorded in the Paleolake Kotla Dahar, now the age axis, which was vertical, is now reversed. So age axis is now the x-axis at the bottom now, and the Kotla Dahar record is the bottommost record. Now this is in line with Mamlu Cave in northeast India, and also marine sediment record from the Arabian Sea and the Gulf of Oman. Now this also is in line with ice core records from Mount Kilimanjaro, which received precipitation from the Indian summer monsoon system also. So this attests the fact that this 4.2 aridification event shown by the pink vertical bar, was a widespread event that was also recorded in the Kotla Dahar Lake and not in the other Thar Desert lakes. This 4.2 abrupt event is also linked with the end of the Indus urban phase and also with the collapse of other Bronze Age civilizations such as the Mesopotamia and Egyptian. Now, the climate phenomena linked with this abrupt monsoon weakening is basically increased ENSO event or El Nino Southern Oscillation event, and which was modulated by the persistent negative Indian Ocean dipole-like conditions around 4.2 K. Now, I would also like to point out that the Lake Karsandi on the Thar Desert margin, or the northern Thar Desert margin, also presents some interesting findings. So this one is slightly different from the other lakes, which are lying more in the interior of the Thar Desert. So Karsandi record reveals that relatively wet conditions prevailed at the northern edge of Rajasthan from about 5.1 plus minus 0.2 kABP. So if you see on the top record, oxygen isotopes in orange show really negative values indicating wet period, and this wet period began at around 5.1 plus minus 0.2 kABP, and this is also the period during which is the this marks the beginning of the agricultural based early Harappan phase of the Indus civilization. Now monsoon intensified further between 5 and 4 kiloyear 4.4 kiloyear BP during the period when the Indus urban centers developed in the western Thar Desert margin and also on the plains of Haryana to its north. So the last date that we have from this section is from this wet unit is at around 4.4 plus minus 0.1 kABP. So after sometime after this age, that is 4.4 kiloyear BP, and an eastward shift of population must have occurred. So the urban phase, which was between 4.5 to about 3.9 kiloyear BP, kind of moved towards the east post 3.9 kiloyear BP. So we think that this kind of drying trend after about 4.4 kiloyear BP could have kind of led to shift of eastern migration of sites, and these findings thus provide evidence that climate change could indeed have been associated with both the expansion and contraction of Indus urbanism, particularly along the desert margin in northwest India, and therefore these lakes, which lie on the margin of desert and now relatively inside of the desert, are critical to understand such relationships. So to summarize, it's quite evident that Northwest Indian lakes present divergent climate histories, and therefore they highlight the importance of understanding local processes and also regional hydrological variations before linking it with the Indus societal changes during the Bronze Age. Impacts of past climate change on Indus cultural changes in the entire region cannot, of course, be based on an oversimplified global monsoon signal coming from other various archives or only from just one regional single climate record. What is needed is a network of well-dated paleoenvironmental records, particularly around the Thar Desert margin, now that the IPCC reports have kind of confirmed that the Thar Desert margin is indeed kind of expanding or moving, and it's projected to further change. It's important to kind of understand, to reconstruct more of paleoclimate records from the margin that spans the entire region occupied by the Indus civilization. So I thank you for your attention, and I'd be happy to take any questions by email, and my email is here. As I could not be present because of prior commitments at my institute. So yeah, feel free to write to me. Thank you.